What are we going to do now, guys? Before we start, I want to make a summary with you. We're going to actually tell you a story because you're falling asleep anyway, so I'll just make it easier for you to be like a bedtime story. Okay? So we'll do a summary of what we have. Why? Because I really need you to understand the concept of ADT versus data structure. Okay, so these two things, some of you are still asking about it. So we're going to give a few examples about it. I think now everyone here. So as I mentioned, we're going to just give a summary. So we're going to call our story on the path to seek the most efficient data structure, volume 1. Hopefully in other courses, we're going to have volume 2. What is the story here? We have Rick and Morty has a software solution company. And from today, we're going to ask people to build their startup here in front of everyone. So what do they want to do? They are always fighting on which data structure to use to build their applications. We're going to make it easier on them and help them. So now we're going to talk a bit about Java because this is the class in Java, but it applies on everything. So how did we start, guys? We said, what is a concrete data structure that we started with? So I assumed that when you came here, this class, you brought with you what? Bag of data structures that we use them to. So what did you have in your bag when you came from the other course, the prerequisite course? I'm not going to put anyone on the spot, but as usual, yes.
Laptop.
Not the laptop. Like what kind of data structures? Tools. Tools, you should get your laptop, of course, to implement things, but data structures, arrays and linked list. So we started with array and linked list as data structure. And then we start talking about the idea of an ADT, an abstract data type. You can remind me, what did we mention about the ADT? What do we need to form an ADT? To formally describe an ADT. Riley. Okay, let's take one by one. So errors, Taha. Operations, which are what? The methods, right? So in Java, they are the functions and methods. So we need to define our operations and also find out the errors that will happen. And most important thing, we need to know the data type that I'm going to put inside these data that I'm creating, right? So I need these three things. What data it can store, what operations does it do, and then the error condition that may arise. What ADTs we covered so far? Anthony.
Covered the linked lists.
Linked list and array, we have it as data structure. What ADT we talked about?
The binary tree tool.
Before that, start from scratch.
List.
The first thing that we did on ADT, stack. And then queue, and then what? Then the list, which is, there is 3 ADTs that we covered in the list. What are they? No, and so we said we have stack, queue, DQ, and then with the list ADT, it's separated to 3 different ADTs. Array list, one of them. What the other type of lists we covered? Sequence, and then, yes, node list. So we covered 3 of these type of lists. They are what? And then, as Anthony said last time, we just covered also trees and binary trees ADTs. Now, what happened to these ADTs that we talked about? We actually, after implementing these ADTs in Java, why we're choosing Java? Because this course, we're covering Java. If it was another course in C++, we would have put C++ here. So we implemented these ADTs in Java. This is our updated concrete data structure bag. So now, what do I have in the bag? All of this, now they are data structures for me. They started as an abstract data type, and then we implemented them. So now they are data structure. Why this is important? Because when we wanted to build this stack, we needed the array and the linked list to be already concrete data structure that I can just call from the library of Java to implement something with it. Now, when I implemented these guys as my data structure, that means if I want to construct a new ADT, I can use for example, queues right away. I can use a priority queue, no, binary tree, sequence, node list right away. I don't have to only stick with array and linked list. So I think we got the idea by now. Yes. Just always memorize this one. When you implement the ADT, it becomes a data structure because then you can call it from the library in Java, for example. If you implement the ADT, so the ADT is just an idea on paper for you. It's just an idea. So I have an idea of stack on paper. It has these operations, these things. So now when you go and you implement it, it becomes a data structure, and then you can use it. Because in ADT, if I tell you you have an ADT, how can you use it? Not implemented. Exactly. When you implement it, it's a data structure now. So it's just like a different terminology, but it's good for you to understand the concept. We said in ADT is very important for us. Why? Because the ADT of a stack can be implemented through two different things. So you'll have two different type of implementations. Guys, I want you to focus with me, right? I don't want to hear. Okay, very good. So now we're going to start with the new ADT. But we're all on the same page for this one. Very good. Very good. Now, while drinking my coffee, we will have Anthony. Today you're in front of me, so if you're comfortable. So we'll have Anthony. And who wants to volunteer to build a startup company with Anthony? I want people who don't usually participate. Almost a volunteer. Anthony, you're not very popular.
Yeah, they'll regret it.
Okay, we have what's your name? Zach. So Anthony and Zach, please come here. Sure. Please have a seat. We're having a new startup company. Okay. Let me see. Now, I'm your client. I'm your first client, actually. You just started the startup. I've heard that you don't take too much money because you're still students, so I'm going to take advantage of this. So I want you, both of you, to actually build me an emergency room system. Goodbye. I'm allowed to leave, or do you want me to? What do you want from me? I didn't hire construction people. I hired programmers. You're a software startup. You're not emergency room system. I said, yeah. So you need to discuss your partners, right? So what do you want from me before I leave?
Okay, so we'd like to know, I guess, what would trigger the what would be the need of this emergency room? Why would we do it?
Very good. So this emergency room is not for war, it's for a hospital.
For a hospital. What are the needs of the patients that go once, I guess?
So, okay, so I want to build a system for the emergency room in my hospital. Be able to serve the patient that enters this emergency room.
And would you like to know how many people
Yes, if possible, I would like to know how many people entered this and waiting to get served.
You need to know about each person that's coming into your home.
Guys, these are very important things, right? Can you hear them or should I give them the mic? Yeah, give So you asked me, he asked me what? Do I need to know the size or how many people are there? I said yes.
Then I asked, what do we need to know about?
each person that's coming into your emergency room?
So technically, I just want you to be able to serve them. You know what I mean? So I want to know how many people come in so they can get what served in the hospital, get admitted technically. Anything else?
Is there like a fixed size for how many people the room can fit?
Actually, very good question. Yes, I'm building this for a very small hospital, so I don't have much space. But I know for sure that it can only fit maximum of 30 people.
Would you like the emergency room to have a layout where we have to pass, for example, nurses and doctors have to pass by patients in order to get to other patients? Or should they be able to access every patient by a door? Without
It's a system, they're not going to feed them. Just need information. Right?
How should we like treat people when they come in? Like, should we, like, when you get a new patient, should it be the first person that came in the door, or should it be?
Actually, it's an emergency room, so I'd like to have the one with the scariest or the most critical condition to be served first. Like if someone has a car crash compared to someone else, then I want the person with the car crash to be served first. Any other questions? Me?
Yeah, sure.
I guess where do we draw the line between we put them in an emergency room or like do we not worry about a regular room, only emergency room?
For them to take the information of each patients. Guys, it's a practice for you to build your own startup. Okay. Now what I'm going to happen, I'm going to leave you to discuss things together and check how can you build the system for me. Okay. Now, also, you're allowed to consult your employees. So everyone here in the class is an employee. Based on his consultation that you're going to do with them, is either I'm going to ask you to fire them because it wasn't good, or to promote them. Okay. So I'll get another one.
Yeah, let's go with Gabe.
So I have two questions. First off, how much are we getting paid?
Good, your unpaid interns.
Okay.
You're volunteering now.
And my second question, which I would have started with, was what are the subsections of your system, or what does it need to perform?
That's what you, we don't have that answer.
Yes. So now you can discuss how are you going to implement this. Remember, you took the class with me, so now so far you have a bag, this bag. So now you're going to discuss what are you going to build? Do you have enough information? So how are you going to even discuss this? Based on what we learned so far, not based on anything else. So how are you going to tackle this thing? So are you asking some questions, and now how are you going to think together? So talk with each other together. Give me the mic.
Use the mic. Okay, so my initial.
Guys, just one thing. Guys, this is part of the classes. We're not doing a play here. So everything they are discussing here is exactly what they're going to explain later. So please focus.
Okay. I think one last question for you.
I'm not here.
Is that, well, I think there's three ways to go down. We either implement the emergency room with like an array-based structure. I don't think using a stack would be very appropriate because like, I think we should have the ability to access every patient at the same time in case someone like is dying in front of us. And somewhere in the middle of the room is dying. Also, a queue doesn't really, in my opinion, fit the purpose, because sometimes it's not the last person that came in. Sometimes someone who just came in needs immediate service before someone else is doing that. So the only other options I think would be just having a simple array-based structure, like a linked list structure or a tree. I would like eliminate the linked list structure right away because then almost each patient is in the room is linked to another patient. And so if you want to get to the last patient in the room who's having some issues, that wouldn't be ideal. That's not, I'd say, like, I guess.
Okay, so we don't waste too much time. Stay here. So,
Yeah.
so you gave me this report.
Yeah.
What I'm going to do, because I don't trust you, so I'm going to go and consult to hire what a private consultation with. He has been working in the field longer than you. I gave you the report, so you've heard how did they analyze. So do you think what they said makes sense? And is there anything missing about tackling the issue? Here, guys, we're not talking about implementation. We're talking about how they are going to think about building the system. So you heard the report from them. Does it make sense so far for you? And did they miss anything while analyzing?
So I don't think using an array-based data structure that we already have is efficient enough. So I think we can use some of the data structures that we have in the back and make one our own, like our own ADT. But using some of these like properties of each one could be useful.
Think about the way that they said, okay, they eliminated the queue. But I'm thinking, as someone who doesn't have a background in software, I'm thinking, you know what, I want, like, it's kind of like a waiting list, right? Because I want them to wait. They get, I thought maybe I can just use a queue.
So generally, like a queue.
Because actually here, he eliminated the queue.
So a queue is actually useful in general when we don't have like a priority. So everybody can be like based on a, first come, first serve basis. So a queue would be nice, but like at the same time, we should be able to, sometimes if there's like an emergency patient that we have to like serve first, then they should be allowed to, pop in the front of the queue. So maybe we can use a queue and add some extra features in case we are able to add in front of the queue as like a priority one.
Okay, great, thank you. Thank you, Anthony, and thank you, Zach. Okay, give them a clap. That's it. Unfortunately, I didn't choose you. You're not going to get paid. You just got the clap. It's good enough for you for now, but hopefully.
An extra 1%.
Maybe. Did you have anything, James? Do you want to share?
Yes, I did.
Thank you. For emergency, I think what could be used best is two queues. That there could be an emergency queue, which you get priority with, and then there would be another queue for low priority.
Okay, also good. So technically, we're still using. We're still using data structure. Okay, now let's analyze what happened here, guys. Let me get rid of these. So we're going to analyze what happened. So the first thing that I liked about Anthony and Zach is that they didn't allow me to leave. Why? Because the first thing that we learned, we want to figure out what's the problem. You remember we said the main thing, I want to know what's the problem. So they didn't allow me to leave. The very famous, the most important question Anthony asked is that, do you want a physical room or a virtual room? Then I answered, no, it's a system. We're not hiring a construction company, correct? So then they actually tried to figure out the problem. And this is very good. So that's very good. The second thing that they started trying to do is to figure out what are the operations. Because if you want to build the ADT, you need to figure out what's the problem, and then you start thinking about the operation that you wanted. So for example, ask me, do I want to do the size or not? That's very good. And then they asked me, okay, how do you want them? Zach answered this very important question. How do you want them to be entered or served? Because if you don't care about, let's say, the priority or the critical condition, then maybe just a queue, I already have a queue ready. I'll just use it. First in, first serve. Or the stack, last in, first serve, for example. But then I answered, no, it's depend on the critical condition. Of course. Then something very important also, Anthony said, do I have unlimited space or a limited space? I said, no, I have a max. Why do you think this question by Anthony was very important for him when he wants to build something? Yes.
Ability to use like either a linked list, maybe an array,
Sometimes you have to go bigger arrays.
Very good. If I know exactly, do you remember when we said if I know exactly what is the maximum that I have? So I told him the maximum that we can get is 30 because maybe it's a physical problem that I have here. It's only 30. So he can choose an array now. He doesn't have to worry about expanding the array because the maximum can be 30. So far, I'm very proud of Zach and Anthony. They did very good job, correct? Now, the next step will be analyzing. So the Q, when he eliminated him, as Taha also said, also James suggested, no, it's not going to work for me. Why? Q is first in, first served. Now, who's familiar with the healthcare system in Canada? When you go to the emergency room, what will happen? Other than you wait 10 hours, of course. If you have a headache, you're going to wait forever. If you have a severe, I don't know what, but then if you have a car crash, they're going to treat you as a priority. So not just in Canada, everywhere. So you need to have the priority. Now, Taha said something very important. The problem with the queue that I have, it can only be like this. If I have something here, I can only access this one. But if I have a priority, I need to be able to access. Let's say this priority is 5 here, but the priority is 2 here. And let's say 10 here, and then 1 here. So 1 is the highest priority. If I'm using a queue, I can only access this one, right? I won't be able to access any of these. That's why actually looking at something that is array-based implemented is not bad. Why? Who can tell me why something like array list would be good? Very good. Same answer. Very good, guys. Do you see now what we did here? You thought that you're not learning anything in this class and you're wasting your time, but you were able to actually tackle a real-life scenario, like a client wants to build a system, and you were able to think, how am I going to build this system? And that's the first step. Why? Because if you didn't know these steps, you're going to jump right away on using a queue or a stack, and then you're going to waste 1 week of implementing it in Java, and then it's going to, okay, it's not going to work. Let's waste another week for it. But here, just maybe 10, 15 minutes, we were able to brainstorm and find, okay, we need something like an ADT. So what we're going to choose actually, guys, is that we're going to choose like something like an array list or a sequence. It's an array based. That's what we've learned so far. I'll be able to access it, but I need to what? Use it, as Taha said, use it and tweak it a bit to create my new ADT. Okay? Yes.
You're working with a client or an interviewer or something. Is it better to start off with generalized questions or more specific ones?
That's up to you. For example, you can start with general questions and then go. Usually it's good to prepare for the meeting. So for example, you'll have a checklist that you're going to ask all your clients to make it easier on you. That you prepare a specific checklist of questions, it will be much faster. Now, when you work in a bigger company, you don't have to do all of these things, right? You're just going to be working on the implementation. But in a startup or something, you need to figure out these things. So I think we took a good amount of time. So let's talk about the priority queue now. We're going to talk about something called priority queue that is based on what we said, that it's a queue, it's a waiting list like a queue, but we're going to add another element, which is a key. We're going to pass another element that it's a key so we can know the priority of this thing. That means if we take again the idea of the emergency room, when you arrive to the emergency, what happens usually? You check in with a nurse, it's going to tell you what is the problem. You're going to say, for example, I broke my leg. She's going to give you like a label, for example, of maybe your priority 10 on the list. If you enter with a what, with like something bigger, like you're going to be given. So that means you is the element. You are the element of this data structure, right? You're the data. But also there is another thing connected to you, which is the key. You will be implementing what in this case? 1 element or 2 elements? Going to have 2 elements inside this queue. One is the actual data and the other one is the key of your priority. Yes, Milan.
The emergency room. Instead of using
No, we can use a sequence. We're going to say sequence now, just why to refer that a sequence can be general. It can be array list or node list or mixed together.
Well, it's prefer a sequence over queues.
No, we're not going to use a queue. No. Why? Because a queue can only access the first one. So we're going to use a sequence, which can be an array list or like array list and mixed with something else. But like the idea is just a sequence. A sequence means a list that I can go and access per index. That's the idea here. Good? Okay. So let's continue. So a set of element with a given priority. So we're just defining the problem here. One can enter in any order. The removal has to be with the priority order. So that's the idea here. The elements are stored accordingly to their priority, as we said, and we're going to talk about it in a bit. So I gave you the example of an emergency room, correct? Who can give me another example where we can actually use this idea? Do you remember when we did the same game with stacks and queues? What about priority queue? Taha.
Task that we have in a computer, like, let's say you have one stuff.
Very good. This is one of the most important thing for a priority queue, multi-threading. And the CPU, what's happening in the background usually, they will treat sometime the request based on the priority. Very good example. Riley.
Not in mind, but like, technically developers have to fill one first, technically.
Very good. Do you see sometimes on anything that, for example, disabled people or pregnant people, women or something? So that's good. Yes.
Be slightly wrong, but like when a service would be have like premium.
Of course, yeah. So that's the same idea. If you have a special treatment, anything, you had your rate.
Yeah.
Exactly. So yes.
Yes, when it shows you the fastest route. GPS
Okay. So the GPS
shows you the fastest route, like, or maybe.
So exactly. For example, that's very good. I didn't think about that. So technically, in a GPS, it has different routes for you, but it's going to suggest the routes based on its priority. For example, what is the priority is the shortest route. So it's going to give you the first suggestion at the shortest route. If you don't want it, it will give you the other suggestion based on the other the next one. Very good. Very, very good example. Okay. Deadline to pay a bill. Of course, no one thought about it because it's still early for you. So deadline to pay a bill is something. If you have a system, you're going to create a system. You want to pay your most important bill first and then go on. Deadline to hand in your homework. Of course, no one cares. So we're just talking about threads and multi-threads and VIPs. I'm kidding. So these are very simple stuff. What you said is actually much more important and more real-world scenarios. So we're going to take the idea of a bill here. So in this case, you have these bills. If you want to choose one of them, you're going to choose based on the highest priority. According to this, which one is the highest priority, guys? James. Gas? Okay. Who said it's credit card? Because I have, this is the lowest, this is the highest. Credit card. So technically here, again, because you're building the ADT, it's up to you. If you programmed something that the minimum number is the highest priority, it's going to be the highest priority. If you programmed it, the maximum number is the highest priority, is going to be the highest. It's up to you guys. But in this example, we said we're going to choose the minimum. Because in the book, I think they are choosing the minimum. So we're going to go with the minimum. And we're going to say, okay, credit card is going to be the highest because you're going to have a bad credit check. And then the phone, because you can't live without a phone. And then you can't live without the internet, but it's okay to live without water or gas. That's fine because your parent will take care of this. Okay. So again, something very important, very, very important. So far, all the data structures that we did, they only have one type of data, which is the element, right? It's either a number or whatever. Now, this is going to be the first time we're going to insert two things, a key and an element, correct? So a key and an element. The element is what is, for example, the credit card or the water or the gas. What is the key? Is the priority. Then you remove it based on the priority. Very good. Okay, so we cover, okay, now this is important. If I have two distinct entries in a priority queue that have the same key, what's going to happen? Again, it's going to be up to you guys. But usually what we do here is going to be, for example, both of them have the same priority, so first in, first serve then at this point, okay? But in real life, in the example of multi-threading, for example, it's not going to be like this. The priority will change because usually in multi-threading, if you have an element, if you have a task that has been there for a long time, the longer it is, usually it's going to advance in priority also, because at the end it's going to stay there forever if always there's a new priority. But in this course, for the sake of the class, we say no, it's fixed, the priority doesn't change. And if you have two same key, the key that has entered first is going to be served. James.
Are we able to make a priority to with the for the value of also T?
No, because it will be very, very limited. You want something general. Always think about it. When you're building an ADT, it needs to cover many things. This one, it will only cover, for example, specific task. Okay. A priority key ranks its element by key in total order. So this is very important. Now we're going to talk with the machine a bit, with the program. For you, you'll be able to figure out the priority based on whatever. Now, we need to give specific instructions for the ADT, for the program to be able to compare these keys. It's going to be based on the total order. I'm sure you've heard of the total order before. So there will be three main property for the total order. That means they need to be, you need to be able to compare them. So comparability, that means X less or equal than Y, or Y less or equal than X. You need to be able to compare these two. You cannot say one of the keys is number, the other key is apples. It doesn't work, right? So there need to be comparability. Also, the comparability needs to be less or equal, not just less. Why? Because the second property is going to be this. If I have X less or equal than Y, and also Y less or equal than X, that means I can also say X equal Y. So I'll need to be able to reach this conclusion. The third one is what? Transitive property. If X is less than Y, Y is less than Z, I need to be able to conclude. So these are just the idea. How are we going to be able to use them? Now, how can I implement this logic? We're going to see it. So how is Java implementing this logic? We're going to see it. So I'll skip these. That's the same idea. Now, keys aren't always integers. Why? You can give me an example. When would key be in alphabet? I'll take it from this side up. Now, who wants to tell? Give me an example when the key, the priority, can be in alphabet number. Yes.
In a process, so we can do it.
Very good. Exactly. What if the priority is, if your name starts with A, let's say I'm taking the keys are the last name to put them in the system. So in this case, is A and B comparable? Yes, they are going to be comparable because they are both the same. And I can say that this alphabet comes before this. All of this can be defined by you guys. Yes.
Letter grades for acceptances.
Yes, exactly. So A, B, C, the letter that you're going to, hopefully you will get an A in this class. So now, because this is a bit of complex ADT, the priority queue, right? It's a bit, not complex, but it's like we need to have more than one thing. So we're going to think about more than one ADT, and we're going to combine them at the end with the priority queue ADT. The first one, let's talk about the entry ADT. So I want to talk about how can I enter something. So what are the methods that I need to know? If I have a data, so my data, my entry is already inside the priority queue. What kind of methods I need to do? It's already there, so I don't want to insert it nor remove it. What can I think about something? What do I want to check?
We can check key, so we can check its priority.
Exactly, we'll check the key or we're going to check the value. That means it's either I give you a key. So for example, I'll come to the emergency room, I'll say, who got hit by a truck? Someone will raise his hand, I know the value of this key, or the opposite. Now, do you remember when we said the total order thing, the logic of how I can compare two keys, we said we need to find a way. How is Java implementing this? Now in the lab, you're going to notice this thing. So Java uses something called comparator. And this is based on one of the ADTs. Now, by default, Java, if you don't specify anything for it, it's going to compare based on integer. But let's say you want something to be a bit more complicated, you're going to define it for the comparator. So what is the ADT of this comparator? It's based on these guys. Is less than. So I'm going to give the first key, the second key, I'll check them. Then we'll have it's less than or equal to, is equal to, is greater than or equal to. So here we're just, because you're going to use it maybe in the lab or in the assignments, for example, we're just mentioning it, but it's the same exact idea of the total order. This is how we implement the total order rules. The three properties, that's how we are going to be implemented through things. Now, again, it's built in for you in Java, so you're good. Unless you want to tweak it and have a specific way to compare them. What else, guys? The priority queue ADT. Now we arrive to the priority queue ADT. Do we know the problem? We know the problem. So what do I need to do here? The operations. Anthony started with the first operation. He said the size of the priority queue. What else? Let's see new people. So we already mentioned many of them. Yes. No, we're specifying the methods, the operations for this ADT. So we said we want to check the size, for example. What else we want to do? Say it. Add something inside the queue. What else?
Assign priority.
Good. So maybe we need to assign a priority. Let's say I want to change a priority. Now, this in real life it is. In this class, I don't think we're going to do this. I want to assume that they already have the priority. Yes.
Priority.
Exactly. So get the highest priority. That's very important for me because I want to check what is the highest priority. Of course, we said we want to insert something and remove something, or said or remove. Okay, very good. So we don't want to waste much time. So we have the size. We want to check if it's empty. That's very important for us. Insert, and always remember the insert is going to give it a key and an element. Correct? Then here, just in this book, and now here for us, we're going to use the minimum. But if you're designing your own, you can use the maximum. That's fine. So don't forget this. If I ask you, is it always the minimum? No. Min key is I want to check what is the highest priority key. Here, I'm returning what is the value in the thing. So that's the difference. Guys, by the way, some of you asked me about the definition of these. You're going to find them in the book with lots of details, but here we just put them in general. Remove min. Now, the most important one for us is remove min. Why? Because based on remove min and inserting, we're going to start analyzing the efficiency, the O of one, O of the big O, I mean. Okay, very good, very good. We're doing good. Okay. So now, I changed my mind. I hired Anthony and Zach. But now they want to start implementing it. So of course, Anthony and Zach, they are very busy, with the public relation, trying to get new clients. So they are going to tell the employees here to do the implementation. So you are the employees of this company and you want to start thinking about implementing it. So with Anthony and Zach, we did the brainstorming together and we figured out what is the problem and what is the ADT. So far, Anthony and Zach gave you that the problem is storing something by priority, right? And then the ADT, they figured out for you that I want to have a priority queue, and then they gave you the methods for that, right? We just covered it in the. Now you're the employee, you're going to say, okay, I want to implement this. What can you use to implement this? Your data structure that you have so far. What did Melanie choose? She chose the sequence. Very good. But now, The sequence. How many implementations we have for the sequence? Let's say we're using array, but what else you need to think about? I'm going to use an array-based implementation of the sequence. Let me see new faces. So I want to think together. Think about this, guys. This is my priority queue, which is based on sequence, for example, array-based. Someone came to the emergency room with what? With a broken leg. So we gave him a priority of 5. Someone else came with a heart attack, priority 1. I'll give him priority 1. And then someone came with a severe headache, priority 1000. Okay. So what are happening here? So now I want, let's see the priority 2 here and then priority 1, for example, here. And then whatever numbers here. If I want to access this, I need to start thinking now about what?
You have something that's really point in the middle with the highest priority. It's gonna take O of N.
Before you tell me what it's going to take, but you as an employee, you want to implement it. So you're going to think about what? You said off, yeah. So I want to, exact. So now, guys, before the action implemented, that's what I wanted to hear from you. Before going to Java, you're going to start writing the algorithm. Do you remember we said it's what? It's P, A, P, P. In this class, we're focusing on the P problem algorithm. So we're going to move now to the algorithm. We're going to choose which algorithm has better efficiency. That means have better time complexity. That means has better big O. Very good. Let's see new faces. Go ahead. Yes, so that's what we said. In our class here, we're going to say, okay, whoever came first. So if you have a heart attack and you came in second person, he's not lucky enough. You're going to be served first. Okay. A question or a solution? Half? Go ahead.
Okay, so, he mentioned that if we had a high priority, we have to loop to get to our high priority element, but couldn't we just store the index of the high priority element every time we add, we check, make sure it's lower than, or if it is higher than, we store that index, kind of like we would do with the head, and then that way we could access the highest priority in the head.
Very good.
So,
Very good. So what is the difference between what Riley said and what? Let's just wait until they are done. What's your name again? Ralph. What's the difference between what Riley said and Ralph? Ralph said we're going to look for the highest priority. Riley said, you know what? No. So they are fighting for a promotion now. Riley said, no, we're going to store them based on their higher priority. So what's the difference? That means when we had them here, we stored them all, and then we're looking for the one. Riley say, no, do you know what? When I store them, because I have them, I want to store them in a priority queue now. I have a list of priorities. I want to store them in priority. I'm going to store it like this: 1, 2, 5. Yes. Very good. I like this. So technically, we're saying here, in this case, Riley's algorithm, we're saying, let's say, each time I want to, so let's say we started with 3 here, and and then we have 4, and then 5, whatever. We want to insert 1. What's going to happen? I have to move all of this and then insert here. So what does this mean? That when I want to insert, it's going to cost me of what? Of n. But here, if I want to remove, it's going to cost me of what? Of n also. In this case, Ralph's algorithm. Do you see what happened? So Ralph's algorithm will solve the insert, but it will not solve the remove. Riley will solve the remove. So that's what we're talking here about. We're going to have 2 things in this case, 2 options for us to think about. Unsorted sequence, Ralph's algorithm, Riley's algorithm with a sorted sequence. I think now I like this. So we're grasping the idea how to think about something. Now, yes.
like the sorted sequence doesn't work really well in terms of when you have two ones, because you wouldn't know which one came first.
You know, so that whenever you have the ones, we're not going to go with these. We just want to understand the main idea. We're not going to go with these very specific things.
Well, you use the information of who came first when you sort it, right?
we can keep a track of this, but let's now not go into these details, just to understand the whole image. And then, for example, in these cases, what you can do when you're implementing it, you just add an if condition or something, or a track it. So you can solve it using implementation, but now just the idea. So again, guys, Riley has this, Ralph has that. What's going to happen? And usually in a company, you're going to ask for more people, and then someone say, stop fighting, stop yelling. Let's just do what Professor Karim taught us in class. Let's just figure out what is the big O, and then we'll leave it for the big O to decide. So we're going to check the big O for both. Then we'll decide based on that. Implementation with an unsorted sequence. We're going to start with unsorted sequence. What's going to happen? We said, because we're using a sequence, the sequence, we already have these defined. It's a data structure for us. I can just call this. I didn't implement it from scratch. I'm calling the add last from the sequence, okay? Now, I added this, and I already explained it. I'm not going to go through it again unless someone didn't get it. So we're going to add it here. It's unsorted. So the addition is going to be O of what? O of 1 to insert, right? O of 1. Now, if I want to remove something, I want to remove 1. First, I need to search what is the minimum. So I'm going to search for 1 and then remove it. That means if 1 is here at the end, it's going to take me off n. So we all agree on this. Who doesn't know why? So I don't move fast for you guys. And at the same time, I don't want to be very slow. Everyone understands this. Very good. So this is the conclusion for me. Whenever I want to search for min key, min element, or remove min, O of n, but inserting is O of 1, then we're going to move for the sorted sequence. It's going to be what? O of 1 to insert, sorry. And the sorted to insert is O of n, and then to remove is O of 1. Okay? Very good. Now, an observation. What is this observation? With unsorted sequence, the remove min always takes O of n with the unsorted. Why? Because I have unsorted, I have to search for it no matter what, because it's unsorted. But in the sorted sequence, the inserting, because we said in the sorted, the insert will take O of n. Always?
There's always callback if you do an insert, you refer to insert.
So technically, it's not always. If they are ordered, right, and the sorted, it may not be O of n. But it takes what? At most O of n, at most. But here, in the answer, you're going to search for it no matter what, because you don't know if it's unordered. For example, by the way, if I tell you, you're a machine. Remember, you're not a human, so you can't tell me I can see what this. You're a machine. So I define this for you as a machine, that this is unsorted. Okay, this is unsorted. But then you're looking 1, 2, 3, 4, 5, 6, 7. As a machine, what are you going to do? Are you going to just take O of 1 to remove? Abed.
Because the machine doesn't have to help.
Exactly. I gave a bad thing because I gave 1 here, but usually let's say 2, 3, 4, 5, 6, 7, because you can say maybe 1 is the initial one you're going to stop. Because the definition of this is unsorted, the machine is going to go through it anyway. Doesn't know. What if there is a 1 at the end? It doesn't know. But if I give you an unsorted, if I give you this is a sorted one and it starts with, let's say 60, you're going to assume that it's sorted. The next one is going to be above 60. So that's the difference, okay? So the unsorted always take off n. Now, the application, another application for the priority queue. Remember, we said sometimes the ADT, you can use it to build an application, but also to build, to be part of something else. For example, priority queue can be an actual priority queue for a hospital, for multi-threading, but we can also use it for something else. The same way we use the stack to build something else. Priority queue, we can actually sort with it. How can I sort? If I give you this that has 100, 50, 60, 210, if you take this and put it inside the priority queue, and then you need to do something, it will give you, it will sort it for you. What do you need to do? Ralph. So which method you're going to call? We don't have a compare. The priority Queue ADT. When you want to get the highest priority in priority queue, which method do you call? No. Remember, priority queue, we can insert, we can check its size, we can check if it's empty, we can check what is the highest priority key, or we can get remove min. We can get the priority. So if you just call remove min, it's going to give you the highest priority. So if I want to sort it from less to like ascending order, I just need to insert it in a priority queue and then call remove min. It's going to sort it for me. Okay, so you can actually use a priority queue to do sorting. Now there is more than one method to do a sorting. Correct? So inserting and then remove min. Who remembers? Who helped me to build to sort my bookshelf? Do you remember someone? I think. Who helped me? Someone came down here and took the book and started sorting with me. What did we do? Do you remember? We sorted the books based on what? Yeah, which two algorithms? Insertion sort and selection sort. So let's try them here. Okay, let's try them here. Selection sort and insertion sort. Why are we doing all of this? Because at the end, you're going to figure out which one is the most efficient. Is it sorted or unsorted? And then even if you're doing unsorted and sorted, which one is better to sorting it? Because let's say I said sorted is better, correct? I decided sorted sequence is better. How can I sort them? I need to figure out, should I use insertion sort or selection sort? Which one is better? So I still need to do a algorithm analysis for these two. Did you get the idea? Okay. So let's start with the selection sort. First, this is just the algorithm. If you want to use the priority queue for sort, that means we're just going to check if it's empty. If not, remove first and then insert, very basic stuff. So let's start with selection sort. What is selection sort? You remember selection sort is that we're going to go through everything, try to find the minimum and take it. Okay, so that's the selection sort. So we're going to look at phase one, the insertion of an item. Before we sort it, we're going to insert first. Let's just take an example right away. So this is my sequence S. It has this. I want to sort it using a priority queue. So the first step, I need to insert inside this priority queue. Okay, so I inserted what? 7. This is O of what? O of 1. Very good. So which one is going to be next to be inserted? 4 is going to be inserted like this, because we're using, again, selection sort, which is unordered. It's correct? So that's 4. Now next, 8. 2, 5, 3. I finished the insert part. So each one of these phases took O of 1. Very good. Now I want to do the remove min. Because this is unsorted, what's going to happen in this case, guys? We're going to loop until I find the lowest one, which is 2. So the first time I did the remove min, it gave me 2. So what did this take? Let's see. The next time I looped again, 3. I looped again, 4. Then 5, correct? Then now 7, 8, 9. Okay. If I ask you a question now, guys. What is the O of n of this part? What is, sorry, the O of the big O of this part? We're almost done, guys. Don't worry. Few minutes, we'll clap. Goodbye. Okay? From here, from this side, what is the big O of the insertion part? Let's see. You've been doing very good. Let's take not someone else from this part. Very good. Yeah, go ahead. O of 1. Okay. Who support him? Who disagree? You support him of 1? Okay. Who support? So a few people. Who disagree? Do you want to say why you disagree?
Because it's O of 1, but it's n times. So
Very good. So it is true, it's O of 1, but each phase is taking O of 1. So if I have n numbers, I'm going to repeat this O of 1 in numbers. Why I'm asking about the bookshelf? You remember we said even if I give you, for example, ordered, at least you want to take the book and put it in the bookshelf. So it's going to take n time if you have n books. Okay, so this is O of n, the total. Now what about the other one? Remove men. Yes?
O
of n. Okay. Who agrees? Ralph?
N squared, because we have infinite amount of elements. Infinite times it's traversing, or n times it's traversing.
Ralph, doing so good today. Okay, Ralph is suggests something different. He noticed there is something that, maybe it's different than O of n. Who agrees with Ralph? Now everyone, because I complimented him. Okay, so look what happened. So Ralph saw this. Okay, maybe it took O of n for me the first time because I had to go through everything, right? But now here I have n minus 1 numbers. Then here I have n minus 2. So I'm not looping n time again. And then here I have n minus 3 until I have 1. So here, what did I do here? I said O of 1 plus 1 plus 1 plus 1 plus I arrived to n. Here, what do I have? N minus n plus n minus 1 plus n minus 2. So what does it remind us of? Gaussian summation, which is 1 plus 2 plus n, which is what? N times n plus 1 over 2 is going to give n squared for us. It's going to be n squared. Okay, guys, so O of n and then remove is going to be O of n squared. So that's why actually selection sort and insertion sort, both of them will end up with O of n squared. And that's why you're going to learn merge sort and quick sort because they are better. Now, selection sort in place, what do we mean by that? The problem here is that Anthony doesn't like this. He doesn't like this. He cares a lot about the space. Here, I'm wasting space. I have one array, and then I'm creating another array, so there is a waste of space, waste of memory. So there's something called selection sort in place. That means I'm going to use the same exact array like this. So this is my array. I'm going to search for 1. Instead of putting it in another array, I'll just put it at the I'll put it here. Then I'll search for the next key. I'll just move it. So I'm just, which is if you think about a deck of cards, it's the same thing. Instead of having the deck of cards in front of you, you're having in your hand and you're just moving them. That's it. So just the idea here, it will take the same amount of efficiency, big O, but it's better on space. Very good. Now we're going to move to the insertion sort, guys. The insertion sort, we said it's the opposite. Why it's going to be the opposite? Because it's going to be based more on the ordered idea, right? It's ordered. How it's ordered? So let's take a look. I want to insert 7 first, correct? Now 4, where are I going to insert it? Before it, it's insertion sort. Each time I get it, I search which one is the minimum, I put it in the beginning because I want to keep an ordered sequence. So that's the idea of the insertion. So now, the second thing, I'm going to take 2. It's going to be at the beginning, and then, okay. So what is this going to cost me? O of what? N squared. Why? Because the same thing here is going to have 1, then 2, 3, and then at the end is going to be n. So 1 plus 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 is going to be n squared. Now the removing, it's already like this. So I'm just going to remove this, remove that, remove. So just I'm calling the first one to remove it, is going to be O of 1. Correct? O of 1 for each phase. That means the total of n. The same exact logic. Now, the only difference, guys, is what? Is that in the insertion sort, inserting the elements into the priority queue, as I said, is going to be O of 1 and then O of, O of n square, and then removing O of n. Now, something you need to pay attention to. Again, you can do it insertion sort in place. We're going to skip these. Okay, so now this is the most important thing for us. It's not the most important, one of the very important stuff. Each time I remove min is always going to be O of n. The same idea you see when we compared unsorted and sorted, the same thing. Selection sort represent unordered sequence. Insertion sort represent ordered sequence. That's the only difference. Because when I tell you, I want you to implement this with an unordered sequence, technically, I'm telling you that you're going to be using selection sort. Correct? Okay. So, but when it comes to inserting with the insertion sort, at most, it's going to be O of n. Why? Because what if they are already ordered? So each time you're going to insert it, you're not going to move anything. So the best case is not going to be O of n. And I made it, sorry, so insertion rost here. Sorry. So the insertion sort represent the sorted one. Worst case, O of n square, but the best case can be O of n because they may be sorted, right? And then for the selection sort, it's always going to be O of n square. So technically, worst case scenario, both of them O of n square. Now, if I ask you a question, I'm just chit-chatting with you, non-formally asking you, but what do you think? Which one is a bit better than the other one? A bit better. Tiny. Look at the tape. Don't think, just look at the tape. Look, so we have method, insert is always O of n, remove min is always O of n square. The other one has a worst case and a best case. That means which one is maybe a bit better? The insertion sort or the selection sort? Exactly, the insertion sort. Just a bit better, even though worst case scenario, both of them, but in this case, at least there is a best case. Here, it's going to be O of n square all the time. Okay, very good. Now I'm hearing woo clap chants. So we're going to do a woo clap and then we're going, oh, by the way, this is the summary for sorting with priority queue. What about the summary of the priority queue itself? So priority queue with insertion sort, which is so the priority queue here, okay, forget about the naming. So the priority queue with a sorted and unsorted. So the sorted is going to be O of n11, 1, and n. So it's the same as the previous slides. We're going to fix them. Don't worry about it. So let's move to the woo clap, guys. Sorry. Okay, so
Yeah, in the other class. It's funny. Being in the class. Like class.
can you see the numbers? Sorry, I mean the barcode. Yes, you can see that. Where is it? Okay, everyone is in. Let's start. Priority queue is a type of queue that arranges elements based on their what? Just a summary, guys. As usual, in case of you slept a bit, took a small nap, maybe you missed a few things. Now is the chance to what? Priority values only. No, not the index and the priority are the same thing. So we cannot say index and priority. No, so priority. So of course, elements with higher priority values are typically retrieved before elements with lower priority. Correct? Of course. Now we're going to skip this one. Choose all the correct answers. A priority queue is an extension of the queue with the following priorities. If I want to treat, yes.
By FIFO again?
First in, first out.
Thank you.
So if I want to treat the priority queue as an extension of a queue, which one of these will be applied to it? Quickly, without talking, 120 people, only 80 answered. Faster. Okay, so we're having this, that. Then people. So first in, first out is still considered. Who said yes and you want to say why? Okay, why?
Well, we still have the order that people go in.
Okay, good. Technically, no, FIFO is not considered in general, but if you answered, it's because when you have two keys are the same, and then that's when you're going to actually treat it, then I'll say yes. Okay, that's fine. But if you answered like this, just like for no reason, no. So technically, no, but in specific cases, yes. Yes.
The last answer isn't necessary.
This one, if two elements have the same priority, they are served according to their order in the queue. Exactly. So that's why I didn't exactly. So we shouldn't have FIFO because I already included this option for you guys. That's what I'm saying. That's why it's I'm
Same. So they're both right.
okay. That's why I'm not being very picky about it. But you get the idea. Okay. How does the priority queue ranks its elements by key? Based on what? How do we rank the elements, guys? Using binary, using priority, using total order relations. So I want to rank the priority. So don't tell me using priority. Okay? Which you already did, for sure. Guys, I'm telling you, these are the priorities. You are the human, you know these are the priorities. We're talking about the machine. How would they understand the priority? How would they know that you mean by A and B, which one is first? Based on what? Based on the total order relation. Remember, sometimes you have to answer like a machine. Choose which one of these, you can have multiple choice, are the definition of total order relation. What are the property of the total order relation? Comparability property, transitive, antisymmetric. Quickly. Of course, all of them. And then are less and equal considered total order relation. How do you guys think? It's definitely by luck, like 50-50. Guys, do you see any less or greater? You can see less or equal, greater or equal. You can't do the less or equal by itself because you're not going to be able to have all of these. So of course, no. Then the last two questions, fun fact, who, when he was a schoolboy, came up with a simple visual demonstration for the one that we just, which one of these four? Don't overwhelm me with number 4. Of course, it's what? It's called the Gaussian summation. So of course, it's going to be Gaussian. Which one is a slightly better insertion sort or selection sort? Just slightly better, a bit. Which one, guys? Insertion sort because it has the best case and worst case. Thank you so much and have a good day.